Hey there, you rates. So this exercise is exercise 5A, Introduction to Algebra. Chapter 5 is all about learning the theory, simplifying, and some of the terminologies that we use with algebra. So here's a good sort of visual aspect of what each of the terminologies mean. So we're going to look at the notes here. We've got an expression, we've got term, we've got coefficient, and we also have equation. Let's start off with an expression. Okay, so we'll start off with an expression. An expression is a combination of letters and numbers. Although sometimes it could just be letters and sometimes they're just numbers. But here's an example. You could have 3 times x. That's an expression. You could have y plus 2. That's an expression. So it's a combination of letters and numbers. But sometimes it could just be letters as well. It could just be a plus b plus c. That's an expression. And a way of thinking about it, an expression is anything that you can be describing a situation. So you could be saying something like, Andrew has some amount of dollars that we don't know. Belinda has a certain amount that we don't know as well. And then Carlos has a certain amount that we don't know. But we know that we can add all their monies together. Something like that. So that's an expression that what A plus B plus C. Let's make another one as well. So it can be add, subtract. It could be multiply. It could be divide as well. So you could say something like, if you have $4 and you divide it by X amount of people. Okay, so you don't know how many people you're going to share it with, but you know you have $4 to start it with. You could square sort of numbers as well. You could do A squared plus B squared if you wanted to. So these are all called expressions. And one of the things I want you to note is an expression is different to an equation. You see, none of that solve because I don't know what some of those letters represent. And so you said, what is A plus B plus C? Well, I wouldn't know. But an equation is actually possible for you to figure out what a number could be. So here's an example that you might have done back in primary school, where I might give you something like magic box. So that's something that we don't know. Plus, let's say 2 is equal to 4. So if I asked you, what is that number? What is that number? Some of us will be able to sort of figure it out through trial and error, sort of logic that we know the number had to be 2. 2 plus 2 equals 4. So this actually gives us an answer. And the reason why it gives us an answer is because of that equal sign. So having an equal sign between two, and fill this in, expressions, because essentially the equal signs on the left-hand side and the right-hand side, you actually technically have an expression. See, an expression and then an expression. Remember I told you that it could be a combination of letters and numbers, but it could just be letters or it could just be numbers. So technically this is an expression. It's 4. And then something, or magic square plus 2, technically we don't use magic squares anymore. We now use letters. And in a way you could also rewrite it as x plus 2 equals 4. And I'm essentially saying something plus 2 has to equal to 4. In other words, x must then be 2. But in primary school, we don't use letters to introduce the idea. We use magic squares because it's a bit more of a intuitive sense that it's a fill in the space. What would that number be? But one of the limitations of using shapes is that there's only so many shapes that you can actually draw, and some of them gets really complicated. Whereas in the letter system, the alphabet, we have 26 different letters that you can use to represent a scenario that you're unsure of. So in a nutshell, what's the difference between expression and equation? An equation will have an equal sign, Whereas an expression is just literally a collection or combination of letters and numbers, and you're just writing a scenario of what it could represent. So up here, what we can see here is this is technically an equation overall. That's an equation because it has an equal sign, as you can see there. On the left-hand side and right-hand side, we can see that there's a set of expressions. We've got an expression on the left, because 5x squared plus 2x minus 1, well, I don't know what that actually is. I don't know what x is, but just looking at this itself, that is an expression, collection of letters and numbers. On the right-hand side, this also is an expression. Now notice that in our terminologies, we've got a term. A term is what makes up an expression. Okay, so it's part of an expression. For example, the ones that we just got up there, when you say 5x squared plus 2x minus 1, these are terms. Now, what are terms? These are the terms. The 5x squared is a term, the positive 2x is a term, and the negative 1 is a term. So how do I know how many terms there are? Like, why didn't I split up the x and the 2? Well, by definition, a way to sort of remember it is it's separated. Each term is separated by a plus or a minus sign. Write that down. Plus or minus sign separates the term, kind of like a comma for terms. Okay, but we don't separate terms when it's timesing. So when they're timesing with each other, so when we write a number next to a letter, like 2x, this actually means 2 times x. And actually that is considered one term, not two terms. So a typical mistake that you should see up here, okay, is that they think this is a term and that's a term. But because it's multiplying to each other, technically you can write that as 3x, and that is considered one term. Okay, and again, it's separated by a plus sign. See how that's a plus? And what are we adding on? We're adding on x times y, or xy. So this is another term. Similarly, on the left-hand side of the equal signs, notice this is 5x squared, and that means 5 times x squared. That's not a plus or minus sign, so it doesn't separate these two, and those two technically is one term. Okay, but then notice it's separated again by a plus sign here, so that technically means this is a positive 2x, and that's separating, that's a second term. Notice this is a minus sign, that separates the 2x, because we're saying 2x and then you take away 1. So when it's add or subtract, we consider that the amount of terms, the different terms, okay? So that separation there technically means negative 1 is a term. All the terms make up an expression. When you have an expression, but if it's equal to another expression, that is called an equation. Does that make sense so far? Okay, so that's what we're learning in exercise 5A so far, is just identifying number of terms, identifying an expression, and knowing when you have an equation. Now, your final one is a coefficient. Coefficient is a fancy term for saying, in this case, the way that I explain it is it's the number in front of a letter. Okay, usually coefficient implies that it's whatever you're multiplying to the variable that you have. So when we say, what is the coefficient AB in the expression above? So up here, let's look, oh, sorry. Did I not have, oh, sorry, here it is. So this is an expression over here. I'll just highlight it again. Here's an expression, because it doesn't have any equal signs. It's got a bunch of letters and numbers. Let's count how many terms there are first. We can see there's a plus symbol here, there's a minus symbol there, there's a plus symbol here, there's a plus symbol there. So we can actually see how many terms there are. There is the 2ab, that's one term. There's the positive b squared, that's a second term. There's a minus 3a, that's a third term. Plus 7b, fourth term. Plus 5, fifth term. So there are 5 terms in this expression. Now what we're trying to learn is, what is the coefficient? So in other words, this is kind of like saying, what is the number in front of AB? So where is AB out of all these terms? We've got 5 terms there. We've got term 1, term 2, term 3, term 4, term 5. Which term has AB together? Okay, because they're saying it's the coefficient of AB. Now, hopefully, as you're scanning through all 5 of them, there's only one that has AB. This has AB. The other one doesn't. The other one is B squared. The other one is an A. The other one's a B. Remember, even if you had something like, even if I put another term and I said 5A squared B, yes, they have an A and a B, but one of them, the A is an A squared. So it's different. It actually has to be exactly what we see, A, B. So when they say, what's the coefficient of AB? The answer is 2. The coefficient is what's the number that's multiplying to the variable. Okay, the variable is AB, and so what you're multiplying to that is currently a 2. Okay, now sometimes the letters, when you just write an A, like the letter A, so that's a letter, and it doesn't look like it has a number in front of it, but what we do know is, if I ask you how many A's do you see right now, well, there's currently 1 A. So we're just too lazy to write the number 1 in front of it to actually tell people there's 1A, because it's pretty obvious that there is 1A right there. Okay, whereas once you have more than 1, we normally write a 2 in front of it, and that means 2 times A. But if you just write the letter A, and I said, what's the coefficient of A? Well, the coefficient is currently 1. Okay, that means the number that's in front of the letter. So let's do a bit of a practice here. Over here, let's look at each term. Let's look at the first term here. You've got 5x squared. 5x squared. So if I were to ask you the coefficient, the language would be, what is the coefficient of x squared? Okay, so that's my variable, x squared. And what is the coefficient? This is my coefficient. So coefficient of x squared is 5. Okay, so this is my coefficient. That's the coefficient of x squared, which is equal to 5. Whereas the next one, if I asked you this one, if I wanted to say the number in front of it, which notice it's a positive 2, we would say it's the coefficient of x. Very good. That's the variable. Okay, so coefficient of x is equal to, whoops, not 5, positive 2. Okay? Which leads to the last bit here. Notice this doesn't have a variable, so we don't call that a coefficient. In fact, this term has a special name. We call that the constant term. And the reason why is because this term does not ever change. It's always going to be a -1. Whereas when you have a variable, which is the letter, the variable can change. We don't know what the letter represents. We don't know what that number represents. And so that's why it's consistently changing. Whereas -1 is very constant. We always know it's going to be a -1. And let's finish off with the coefficient thing again. So if I asked you, what is the coefficient of xy? So the coefficient of the variable right now, I've got 2 letters there. I've got xy. Well, the number in front of xy, even though you don't see it, it's not 0. Clearly, I've got 1 xy sitting there. So it's actually, even though you don't write it, it's a 1. It equals to positive 1. Okay, so that's all the terminologies that you need to know for exercise 5A. You need to know what is an expression, a term, a coefficient, and an equation. Let's do an example. I'll fill in this table later, but these are just some of the key words that you need to know about what is add, what's another word for add, what's another word for subtract, multiply, and divide, but we'll come back to this. Let's do a practice just so that you feel a bit more familiar, okay? So remember, as a reminder, when you write 2 letters next to each other, that actually means A times B, okay? And the reason why is we're just too lazy to write the time symbol, because in mathematics we do a lot of multiplications, and so hence we're too lazy to write the time symbol, and so we just combine them when we know that we're multiplying them together. So for example, 4 times B, we're too lazy to write 4 times B, so we write 4B. and that means the same thing. It means 4 times the b. Okay? And same thing here. Instead of writing a times b, we can just write ab. It's one less operation or symbol to use. So when you say 12ab over here, what this actually means is 12 times the a, and the a is also multiplying to b. But you can see which out of these two do I prefer writing. I prefer to write 12ab than to write this, because that requires an extra 2 symbols. And then similarly, when you write 3 bracket a, that actually is still the same as saying 3 times a. Okay, so in between the bracket and the 3 is actually a multiplication symbol there. So that's another way of saying 3 times a. Let's do an example so you get a bit more used to what the exercise is about. So here's example 1. Example 1 says, list the individual terms in the expression. So notice, why is this an expression? It's because it has no equal signs. Okay, it has no equal sign. It doesn't equal to something else. So it's actually impossible to solve if you don't have an equal sign. So here in this expression, they're asking us to list the individual terms. So remember, the terms are all separated by a plus or minus sign. So in this situation here, we can see that for a, I'm adding, so plus, that separates the term. So I've got one term here, plusing a b, so that's my second term, and then I'm minusing a 12c, so that's separating it again. So every time you add or subtract, it separates the terms, right? So 4a is a term, positive b is a term, negative 12c is a term, and then finally 5 is also a term. So how many terms are there? And they want you to list them out. The terms are for a, you've got a positive b, you've got a negative 12c, and you've also got a 5 as a constant. Okay? Then when we look at b, question b, it says in the expression, which is the expression we've seen, 4a plus b minus 12c plus 5, state the coefficients of a, b, c, and d. Now let's see. Coefficient, remember, means the number in front of. So here we go. Coefficient of. So if I ask you, what is the coefficient of A? The coefficient of A means the number in front of A is 4. Actually, I'll write it all as a sentence so that you can see. Coefficient of A is equal to 4. It's what's multiplying to A, the variable. Okay. Then I say, what is the coefficient of b? Well, b is here, and remember it's a positive b, and even though you don't see a number, it's not 0, the number is actually 1, because we can clearly see there is 1b right here in front of us. So hence it's positive 1. Then I can say, what is the coefficient of c? Which means what is multiplying to c, and at the moment we can see it's negative 12. So it's minus 12 or negative 12 is the coefficient of c. And then the last one, they say, what is the coefficient of d? Now looking at the expression above, I don't see the letter d. And if I don't see the letter d, that must mean I have 0 of them. Because if I do see the letter d, it would mean that I have at least 1. Right? But because I don't see the letter d, the coefficient of d must then be 0. Does that make sense? All right, and then let's go with question C. C is asking, what is the constant term? And remember, I said the constant term is the term that never changes. Or another way to remember it is the one without a letter. And out of all the terms that we listed so far, we had a 4a, a b, a negative 12c, and a 5, the only one that doesn't change is 5. 5 will always be 5, whereas b, I don't know what b can be. B could be any number. So it could have been 100 for all I know. A, it's 4 times a over here. I don't know what a is. If a was 2, then 4 times 2 is 8. If a was 3, because we don't know what the letter a represents. It's a number. We just don't know what it is. So 4 times 3 would be 12. So because I don't know what it is, there are infinitely many possibilities. Whereas 5, it's very factual. It's just 5. So we call that a constant term. So this is a constant term. So constant term is equal to 5. And then lastly, D, state the coefficient of B in the expression. So they've given you a new expression here. They're asking the number in front of B. Now, I know there's quite a few B's here. There's a 4AB, there's a B squared, there's a 7B, but out of them all, we were asking for the coefficient of B, not B squared and not AB. Okay, so this is an AB, that's a B squared, but we were asking, what is the coefficient of B? So the coefficient of B must be 7. Okay, so when they say coefficient of B for this expression, coefficient of B in this case has to be positive 7. Okay, so when you're doing these coefficients in the questions in the exercises, just be careful. The signs in front do matter. Had this been a minus rather than a plus, then you make sure to write negative 7. Okay, but because it's positive, you don't have to write the plus sign. You can if you want. We're just too lazy. For most positive numbers, we just write the number, and when it's negative, we put a negative sign. Okay, so that's all you need to know for exercise 5A. To fill in this table here, let's do a couple of keywords that might mean add. You could have most of the keywords is sum. That's a keyword that we often use for addition, but we can use other words like increasing. So if your salary increase, then we know that's an addition. We can have together. We can have what is add, increase, plus, addition. Those are the words that you can think of. You can think of more if you like. Another keyword for subtract is difference. So these are the kind of words that they often use, but sometimes they can use other words like decrease, reduce, subtract, minus. Those are words that could mean subtract. What's a proper word for multiply? We usually use the term product. That's a key word. So I'm boxing all the key words. But then what's another word for multiply? You can have groups of, times. The word of itself means multiply. And then divide, a keyword is quotient. So quotient is those 4 keywords you must know. But otherwise, it's what? Divide, share. What else means divide? I'm at a brain fart at the moment. I think divide, share, and quotient. Well, if you can think of any others, fill it in. Otherwise, let me know when we're back in class. But there we go. These are the terminologies that you need to know. Here's the example that you would be doing. And these are just some additional terms that would be helpful for you to understand what the words mean. So they'll give you some sentences and they want you to rewrite them. So for example, this one here, they might say the sum of 3 and k. So we've got 3 and k. What are we going to do with those terms? We are going to sum them. And so essentially that just means 3 plus k. Okay, but you had to know what the word sum represents. And I've done the examples down here for you to sort of see there. Okay. All right, team. I'm going to stop the video there and enjoy.